Okay, this is lesson 8.2, multiplying and factoring polynomials. Today's learning target is to multiply a monomial by a polynomial and factor a monomial from a polynomial. And just so you know, we've talked about it in class, but a reminder that the MSP for the 8th grade students is coming up, and also the end of course exam. So your job is to be working on all the skills you've learned this year and refreshing your memory and reviewing. Okay, here we go. When you multiply a monomial, remember a monomial is just a single term. When you multiply it by a polynomial, in this case, you have a trinomial, remember that's 3 terms. It's just like any other multiplication, you're just going to distribute. So really what you're doing when you're multiplying a monomial by a polynomial or a trinomial is just distributing, and it's taking what you've learned about the distributive property and what you learned in chapter 7 about exponents and combining the two skills. So I'm going to write it out. You might be able to do this without writing it out, but I want you to see the steps. I'm going to multiply negative x to the third times 9x to the fourth. And then I'm going to subtract and multiply negative x to the third times 2x to the third. I want to make sure that's clear. This subtraction is this subtraction, and this minus is this minus, or negative. Then I'm going to multiply negative x to the third times 7, and that's plus negative x to the third times 7. So now that I've distributed the first monomial to each of the terms in the trinomial, now I'm going to simplify. A negative times a positive 9 is negative 9. That's this part and this part. X to the third times x to the fourth. When I have like bases, I add the exponents, so that's x to the seventh. Next term, I have 2 negatives, so that makes positive. 2 times 1 is 2, and x to the third times x to the third is x to the sixth. And then the last term, I have a negative x to the third times 7, which just makes it minus 7x to the third. And that's it. Okay, so now it's your turn to give it a shot. Simplify this expression by multiplying this monomial 5n times this trinomial. So go ahead and hit pause and try this on your own, and then when you're done, you can hit resume. Alright, the next problem has to do with factoring, or finding the greatest common factor. And we looked at this a little bit before spring break. But essentially, all you're going to do is take each of the terms and find the greatest common factor. So, like we did before, I'm going to write out 5x to the third, 25x squared, and 45x. And to find the greatest common factor, I write it out as a product of prime numbers. So 5x to the third I can write out like this: 5 times x times x times x. 25x squared is 5 times 5 times x times x. And 45x is 3 times 3, which is 9, times 5, which is 45, times x. So to find the greatest common factor, all I do is circle all the factors that each of these numbers has in common. So there's a 5 in common, and there's an x in common. No other numbers in all of the lists show up for each number. So the greatest common factor is 5x. And that's pretty straightforward. And once again, take this opportunity and try this problem on your own, maybe. So hit pause and then try it, and hit resume when you're ready. Okay, if I have an expression like this one, 4x to the fifth minus 24x to the third plus 8x, I can find the greatest common factor, but then what I can do once I've found the greatest common factor is factor it out. Now, I don't think you've seen factoring yet. Let me describe it to you in this way. If I have an expression like this, what I do with the 2 is I distribute it. And I get 2 times x plus 2 times 1, or I just get 2x plus 2. When you factor an expression, you do the exact opposite. You find the greatest common factor of an expression, and in this case it's 2, and you factor it out, and you go in the exact opposite direction. So when you factor an expression, you might start with it something like this, 2x plus 2, and when you factor the 2 out, you end up with an expression like 2 times the quantity x plus 1. Now, if that confused you, that's okay. That was just to get you set for the example I'm about to show you. So let's look at it. 4x to the fifth, 24x to the third, and and then 8x. So I'm just going to write them out like I did before. 4x to the fifth, 24x to the third, and 8x. Now, notice I didn't bother with the sign. There's two different ways you can do it. You can include the sign or not include it. I'm just going to include just the numbers. So 4x to the fifth written as a product of primes is 2 times 2 times x, 5 of them. 24x to the third, 2 times 2 is 4, times 2 is 8, times 3 is 24, and x times x times x. And the last one, 8x, is 2 times 2, which is 4, times 2 is 8, times x. Okay, the greatest common factor for all three of these terms is, let's see, there's a 2, and there's one more 2, and there's one x. So the greatest common factor is 2 times 2, which is 4x. Now that's great, but that's not the answer. That's just the greatest common factor. And what I'm going to do is factor that out of this entire expression. So I'll write 4x, and then I'm going to write what's left once I factor that out. Now by factoring it out, it means I'm taking those factors away from each of these numbers. So if I take 4x out of the first term, meaning I take the 2 and the 2 and the x, the only thing that's left is x, 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 which is x to the fourth. I've factored 4x out of 4x to the fifth, and what's left is x to the fourth. Then I'm going to factor 4x out of 24x to the third, which, same thing, I'm going to take the 2, and the x. Those are all the common factors, and what's left is 2 times 3, which is 6, and x times x, which is x squared. And I'm going to put the same sign that was there originally, that's a minus. And then I go to the last term. If I factor out 4x out of 8x, I'll take out the 2 and the 2 and the x, and what's left is 2. So the answer, when I have factored out the greatest common factor, is 4x times the quantity x to the fourth minus 6x squared plus 2. And that's the answer in factored form. Now, how do you know if it's right? Well, if you go backwards and you distribute the 4x, you get 4x times x to the fourth, which is 4x to the fifth, minus 4x times 6x squared, which is 24x to the third, plus 4x times 2 is 8x. And what you get back is what you started with. So just so there's no confusion, this is the answer. The rest of it is what I do to check my answer to make sure that it's correct. So try this one on your own. Hit the pause button. When you're done, hit play, and I'll go through this one with you. Okay, first thing I'm going to do is write out each of these terms and find the greatest common factor using prime factors. 9x to the 6th is 3 times 3 times x times x times x times x times x times x. 1, 2, 3, 4, 5, 6. 15x to the 4th is 3 times 5 and 4x's. 12x squared is 2 times 2, which is 4, times 3 times x times x. So the factors they have in common, well, there's just a 3 and 2 x's. So the greatest common factor is 3x squared. 1, 3, 2 x's, that's 3x squared. So I write the greatest common factor on the outside of a set of parentheses, and what I put on the inside is what I get when I factor out 3x squared out of each of the terms. So if I look at my lists that I've made, the only thing that's not circled in the first number, 9x to the 6th, is 1, 3, and 1, 2, 3, 4 x's, so that's 3x to the 4th. Plus, next number, the only thing that's not circled, 5, and 2 x's, which is x to the 2nd power. And then the last number, 12x squared, the only thing that's not circled is a 2 times a 2, which is 4. And that's the answer. And again, I could go back and distribute, go backwards to see if I got the right answer, but I'm going to tell you this is the correct answer. Okay, problem 4, last problem. This one's a story problem, and you can use what you've learned so far to solve this story problem involving this helicopter. So it says a helicopter landing pad or a helipad is sometimes marked with a circle inside of a square so that it's visible from the air. What's the area of the shaded region of the helipad at the right? So we're looking at this part that they've done marked in red that I'm outlining in green. And what you know is you have a square. So you can draw a picture on your paper. I'm going to draw that a little bit better. And cheat. Draw a square. And the dimensions of the square are 2x. Since it's a square, if one side's 2x, the other side's 2x. And inside the square is a circle. And the dimensions of the circle has a radius of x. So if you know the area of the entire square and you cut out the area of the circle, that will leave you with the area around the circle inside the square. So first thing you should do is make a plan. The total area that you're looking for is equal to the area of the square minus the area of the circle. That's the first step. How do you find the area of a square? You multiply one side by the other side. 2x times 2x. Minus, how do you find the area of a circle? Pi times the radius, which is x in this case, squared. So if I simplify this expression, I get 2x times 2x is 4x squared minus pi x squared. I'm almost done. If you look at this expression, you'll notice both of these terms include an x squared. X squared is the greatest common factor for this expression, so I'm going to factor it out. X squared. And if I factor an x squared out of the first term, then what's left is 4 minus, and if I factor x squared out of the second term, what's left is pi. So the expression I have when I'm all done that represents the red area in this helipad is x squared times the quantity 4 minus pi.